We can understand immediately if there is a problem in the circuit, in the sniffing circuit, or if our, I don't know, if our tuner is not well centered to the frequency we want to sniff.
Yeah. So it's very important from debugging that we can actually see if we're doing the right thing or not, because you're playing with electronics, you get 0 and 1s, things mess up very easily. So, but this way you can actually see if what you're building is actually correct. And here you got a link for the assembler code we use for the peak programmer, so everything can be made from scratch. So this is the output. This is actually a very low quality output. So you can see we got some 1s, some 0s, and then we got some bad quality data. This is an oscilloscope, and this wave here. So this is the pure RDS signals.
Yeah, this is the analog RDS signal.
So our goal is getting from here to here and potentially have lots of 0s and 1s so that we're happy. We can decode things, and then we can play with binary, which is much more cool than play with C code or whatever. We can see binary. It's awesome. So RDS protocol. So how does it work? The RDS protocol is very, very simple because it's made for being space efficient. There's not too much bandwidth on RDS. Okay, so we want to be space efficient. So what happens here? We have 4 blocks. So it's 104 bits. We have block 1, 2, 3, 4. The first block, so every block has 16 bits of data and a check word, which is like a checksum of 10 bits. Okay? The first block has what is called the PI code, which is program identification code, which is a number, which is related to your broadcaster. Every broadcaster has its unique number, okay? And it's public. You can find it on the internet, okay? Then you got a check word, so this PI code is 16-bit. And then we have block 2, which we have the group code, which is going to tell us what kind of packet this is going to be. So as I mentioned, to do with RDS, we can send alternate frequencies, we can send TMC, we can send the name of the station, so lots of different things. So the type of message we're sending is decided by the group code. So depending on what this group code is, which is 4 bits, these 5 bits and the contents of block 3 and block 4 will be, will change, will be dependent on that, on what we put here. So our application, our navigation system, or your radio station, the first thing it does, so it checks the PI code if it's relevant to the station we're listening to, then it checks the group code, and according to what packet it is, then it goes to the code, everything else. This is the version code. This is TP, the traffic program, so that's the one responsible for stopping your CD and falling back on your radio if you're setting that functionality on. The PTY code tells you what kind of program you're listening to. So if jazz music has a code here, blues music has a code here, whatever. And these are free 5 bits, and then of course we have the check code. And the other 2 blocks are completely free. Okay? So TMC uses that in this fashion. So block 1 is PI code and check word. That's always the case with every RDS group. Block 2, we still have the group code, we still have TP, we still have PTY, and then here we can see the things change. We have something T, F, TP, and then we have other things here in block 3, and then we have a location code in block 4. So what are all these for? So the T, F, and D are used for something called multi-group message. So with TMC, we can either send a message within 4 blocks, or if you want to send more information, we can use more than just 4 blocks. We can send different groups, and that's a multi-group message, okay? Think about TCP/AP, you do packet segmentation, okay? So this is a similar thing. Then we have a duration and persistence of the event. So we get a queue. How long that queue is going to last? We get an accident. How long an accident is going to last, okay? That's been specified in the duration and persistence bit, which is I think it's 3 bits, okay? Then we have diversion advice. So if we have a warning about emergency telephones not working or rain, we are likely not to get a diversion advice from your satellite navigation system. Your satellite navigation system is not going to tell you, oh my God, the emergency telephones are not working. Please take a different road. That's not going to happen, of course. But if you get a serious accident or a fire or the road is closed or you get a severe queue, then what they do is they put 1 in the diversion advice bit, and then your navigation system is going to pop up. Warning, look, there's a queue. Would you like to detour? Or would you like to return to your current route? Okay, so that's what's going to happen. Then we got the direction bit. So you have a highway, okay, and you want to know if the event is affecting this direction or the other direction, okay? And that's set in this piece, so it can be positive or negative, okay? Then we event the event extension. So I have a queue. How far does this queue go? Could it be 1 mile? Could it be 2 miles? Could it be 3 miles? Okay. Or if you have an accident, which is brand new, it can only be local. Okay. Or you have like snow, because TMC is also used for giving you weather information. Okay. So if you have heavy snow, how far is the area which is being covered there? Okay. So that's here. And then we got the event code. So the event code is the actual a number which is associated to a table of events, where you can see, number 123 is a queue, number 652 is an accident, or whatever. And this is a subset of the traffic management data dictionary, okay? And it's something that is stored on your navigation system, okay? So because we want to be space efficient, we just send a code, and then your navigation system looks up that code so that you can, translate that number to something that is useful for you, okay? And also, very important thing, we have finally the location, which is a 16-bit number. So what happens here? With TMC events, you don't get GPS coordinates in the message because there's no bandwidth for that. So you just get a location code, which can be only a 16-bit number. Okay, so we can have 6,535 locations. And so what happens is that in every country, there's a different location table, which is stored on your navigation system, okay? And so the navigation system resolves the number in the message to the GPS coordinates, okay? So the problem here is that you cannot have a TMC message wherever you want. You can only get it in locations that are supported by the geolocation table and then actually encoded, okay? So what they do, you have highways, you have major roads. In some cities, you have major arteries in your city, or you have ports or whatever. But you cannot place an event wherever you want. So that's the limitation of the protocol. Okay. But rightly so. So they found out since we have not much bandwidth, I mean, we do not care about putting a queue in the middle of a farm or whatever, or in the middle of the sea. We just code whatever major roads we have. Okay. And the location table, which is encoded in a specific format, in a specific standard, sometimes it is public. So, for instance, the Italian location table, you can just download from the internet. Our government is so kind, and you can just have it, which helped us greatly. Or what you can do, you can also rip it from the navigation system. So if you have a built-in navigation system with a DVD on it, so you can take the DVD, you can put it on your computer, you can use strings on it, you can, sometimes they're encoded, but they're not really encrypted, so you can get the location table if you want, okay? So, as I was mentioning to you, we wrote a tool which is called Simple RDS Decoder for decoding messages. So what it does is so it's open source, you can download it here, and it tries to do full RDS TMC decoding. And that was vital for us, for understanding if our circuits were actually working for decoding the protocol, then change it, and then send whatever we want, okay? So think about Wireshark, if just for RDS, okay? And you also perform basic decoding of RDS, so you can see the station name, you can see alternate frequency stuff, which was also very important for understanding if our circuit was tuned properly. Because we tune to a specific radio station, we have our software decoding the name of the station, so if the name actually matches the station, makes sense, it means we're doing the right thing, okay? And then we mean that if we can go and decode TMC messages, we're going to see the real thing. Because if you think about it, we have all zeros and ones, we have like a 16-bit number, and this is carried over analog, right? So you can get static noise, you can get lots of problems. And if a zeros get a 1, or a 1 gets a zeros, you're still having something that makes sense to you. It's just that it's wrong. And the only way for understanding that is by checking the checkword itself. But the checkword is not safe. It's not like using SHA 256. I mean, it could be wrong as well. So you shouldn't trust it. And one way is actually checking the name of the station. So the first thing you have to do is you have this long string of zeros and ones. So you have to understand where to lock for getting the beginning of your RDS message. Okay. So as we saw earlier, the first block of every RDS group has PI code as the first information. Okay. And the PI code stays the same for your broadcaster. Okay. So what you can do, you can just simply look for that string, because that is going to be the most recurring string in your data stream, okay? And for knowing it, you just, Google for it. And if you, don't know how to get it, you can just, you can use our tool with this flag, and it's going to show you the most recurrent string in your stream, which in this case was like 5218, and it so happens that 5218 is the PI code for one of the Italian broadcasters, and it was actually the one we were tuned on, okay? And 5, every Italian station begins with 5, okay? So if you go to the States or other countries, you get a different number, okay? And then, so you can download the location table from the internet. So what you just need to do, you invoke the tool with a proper PI code, which you find out in, other ways, and then you specify the location table, and then you pass the raw file, which is just zeros and ones, and what you get are the decoded messages. So this is one message, this is tuning information, and we got here, so what we have here, we get the program name, so we see RT. So the name of the station here is RTL 102.5. So what happens is that in every group, you only get 2 letters because there's no bandwidth for more. So you get 2 letters, and 2, and 2, and 2, and 2, and you construct the name of the station, okay? So here we only have RT. So this binary here stands for RT, okay? And also the tool is so kind to give you all the collected letters that you had before. So it caches what you've seen earlier, and then it gives you, the full name of the station. So when you start the tool, you actually see the name being constructed. You see RT, RTL1, RTL102, and then .5. So you actually check what's going on, okay? And here you have the raw data. So you have the data, the checkpoint, and the hexadecimal of all the different 4 blocks, which is useful for actually matching all this information which is decoded. Then you can change it, you can replay it, and do bad things, okay? So this is what we got from the air, and this is actually the decoded message, okay? This is finally a TMC message. So the group type is 8A. So 8A is being used for TMC. You can see there's a program identification here, which stays the same. It's 52108 here, and it's 5218 here, okay? Same thing. Then what happens here, we have a decoded group, okay? So we have duration and persistence. So 0, they're not giving any explicit duration. So what happens is your satellite navigation system is going to keep that event for whatever it thinks it's default, okay? Diversion advice, there's no diversion advice here. The extent is free. Free what? Free, we don't know. The satellite navigation system decides, okay? Then we have the event, which is number 115, which means slow traffic. And then we have the location, which is 3084. Then our tool goes on the location table. It decodes the location. And this is a big road in Rome. Okay, so we get the name of the road, we get the road code, and we get the GPS coordinates. Okay, so what we see here is slow traffic in a big area of Rome, which makes perfect sense. Okay, because Italian traffic is crazy. But you have crazy traffic too, so probably friends in that. Also, one thing that you have here, you have a Google Map link. So you can actually click on it and go to the GPS coordinates and see if your event actually makes sense. Okay? So this is TMC working for you. Also, one important thing, for TMC, we have 2 kinds of messages. So in 8A, we got the actual events, and in 3A, we got the system information. So what happens, this is used for detecting the presence of TMC on a specific channel, because your satellite navigation system needs to know where TMC is being broadcasted. And for doing that, it checks for 3A messages, okay, which gives you the location table number you're using, and gives you the scope of the message. It could be international scope, it could be national, it could be regional. The reason for it is international here is that in Italy we have borders with lots of countries, okay, so we have France, Germany, Austria, Slovenia, so it's not uncommon to get messages from other countries, okay, so usually what they do, they broadcast on an international scope. Or sometimes, the broadcasting station, they just set that to 1 because they don't know what, they're doing. So don't assume they're using this in a smart way, okay? It never happens. So as we see in this message, like the duration and persistence is zero. That's never used properly most of the time, okay? And this is a plot on Google Maps, so we use the Google Maps API for plotting all the events. You can see we got lots of events here, which is Rome. We got lots of events here, which is in Milan. We got lots of events on this road. So if you live in Italy, you actually know